Hello, welcome to this Unreal Engine tutorial. I'm the Festmaster. Today I'm going to be continuing on with blueprint interactions, and today I'm going to be covering using direct references for two blueprints to talk to each other. This is a very basic, simple system. You basically have a reference to the object that you want to call a function on, that it has that function in it, and then you use that reference to call it. But it can get more complicated than that depending upon how you are getting that reference. So starting with what we had last week using blueprint interfaces, I'm just going to delete this, and we're going to modify this interactable machine so that it can call a function in another blueprint object, and in this example we'll just have it turn a light on or off. So to begin with, we'll actually be creating that blueprint. And so we'll just create a new blueprint of a static mesh actor class. And we'll call this light. Now opening this up, I'm going to go to, okay, never mind. In here, with this static mesh component, I'm just going to search for shape, if I can type, sphere, here, and then just find a nice material to give it, much like before, and then I'm going to be adding a point light to it. Drag this above it, change its color to a deep purple, and up the intensity so it's easier to see. Compile and save that. Now, in the event graph, or in any graph, we can create a new function called toggle light. And this is the function we're going to call. And we can get this point light and get whether or not it is visible, invert that, and set its visibility. So every time you call this function, if the light is off, it'll turn on. If it's on, it'll turn off. Then enable propagate to children, even though it doesn't have any children. Very simple. And then we can just drag this out into our level, and we've got a nice purple aura. And then if we go over to our interactable machine and open it up, we can just delete all of this code on the event click, because we no longer want it to change colors, we want it to turn that light on and off. So what we can do is create a new variable and call this light. And then under the variable type, we can search for light. And we made a static mesh object, which is easy to see by the little house. Static mesh objects have this little house as their icon, and we want an object reference to that. Now, I probably shouldn't have called it light because there are other classes named light, but that's okay. And now with this light, we can enable instance editing and compile. Now if we go back to the map, we'll notice under the default we have this light. And if we click the eyedropper, we won't be able to select anything else except for this light object. And now it's set the reference in here to any light object to be to this particular light object. And then we can take this light object and get it and then call toggle light. compile that and play, and now when we click on this cube, it'll toggle the light on and off, though there is no player interaction, which is what we built the last time, on the light itself. And that's the gist of using direct references to have interaction between blueprints. You can do the same sort of thing with any type of actor. For example, if you had a text render like this one here and a reference to a text render, you could set it to something. So if we go into our interactable machine, we can actually create a new variable, call this text, change the type to a text render actor object reference, compile, and then grab this text, and we can do functions like set text for the text render component of the text render object, and then make some literal text, type classic hello world, and then if we just move the existing text render from the template down a bit so we can read the whole thing. I forgot something. We have to make the text instance editable so we can edit it in the editor. And then again, select the eyedropper. We can't select anything else but the text render. Then when we play, if we click on that, it'll change the text render to say hello world. And I misspelled it, of course. So that's the essential gist of using direct references. Now, of course, you can always, well, if you're doing something like get it from an overlap, and I'm just going to, on our interactable machine, because I'm just working with that at the moment, we can put a box collision on here, call it box. Our viewport, we can make this rather large. Actually, let's make that even bigger. Put this very large box collision component on here. The collision presets we can set to custom, overlap all. So this will overlap everything. And then, let's say we want this to basically auto-detect what light to turn on. So we can turn off the instance editableness of the light. And then, on the begin play, if we get the box, we can get the overlapping actors. We could put a class filter on here, but I'm just going to leave the class filter to be actor, because that's more similar to what you'll get out of a event overlap, which you can do this basic same thing with this, and then we'll just do a for each loop, because we have an array of every actor that is currently overlapping this box, and cast to light, and we did a light with a lowercase, so that's this one. And if it is the light, we can set the light. And so if we select this box, we'll notice it's rather large, and we can put 2 lights inside of it, and we'll put 1 light outside. If we play and click on it, not much of a difference. So, well, that's probably because I left both lights on the same side. We'll put 2 lights inside of it on different sides. Okay, interesting. I might have a problem somewhere. Well, we've got a free lesson on debugging. We'll see if this is properly looping. It's only looping once. Oh, I know why. I forgot to turn on generate overlap events for these lights. And so you notice it's only turning one light on and off, even though there are two in the box, because it only has one reference and it's the last light that it finds. And it definitely will not be doing this one. Even if we delete both of these lights, it will not affect that light at all because it's not within this volume. And so that's another way you can get the reference to something. This is an auto detect one. Obviously, you can do it with a box using the begin overlap, the other actor, or if you're working with components, the other component. So and then you just have to do a reference, or not a reference, a cast. Where is it? Here. Which can lead to long cast chains of you're casting it to one thing, it fails, cast it to the next, that fails, which is why you would want to do a hierarchy of things, basically. So you'd want a base class of like a toggleable base class that has a function in it, toggle, and then subclasses of that would be like light, and then something else that you want to be able to be toggled, and then another thing you want to be able to be toggled, and they each override that toggle function on their own. And then you just cast to the toggle class and run the toggle function, and then the subclasses will also get that function in them. So we can actually do that right now. Rather quickly, we can just make a base class of a actor, call this toggleable. No, that is not the button I wanted to click. And then in this base class, we can create a function called toggle. And that's all that needs. And then if we go to create a child blueprint class, we can call this toggleable light, add a component, point light. Again, I'll just make this one blue for difference. Again, increase the intensity. And then with the functions, we can go override, toggle. And you'll notice that it did this as an event. And that's because in this toggleable function, we didn't add a return. We can make this a function by adding a return node. And it may need a actual return value for this to work. I do not remember off the top of my head. And then we can delete this, re-override that toggle. Yes, and it does need a return value, so we can just create one quickly. And now we have an error message. Override toggle. Okay. There we go. And now we have it as a function. And this parent toggle node runs this toggle function. However, this is not something we're going to need for that. That's just a point about it's a point about overriding functions. So we can just take our code in our light and copy it over to the toggleable light and use its own point light system. Compile that. Well, toggleable needs some collision, so we can just add a sphere collision to it, and make it overlap everything, simply so we can detect it. And so our toggleable light is just a light within a collision sphere. And then we can change our interactable machine. Instead of searching for lights, we can change this to a toggleable object reference. Yes, change the variable type. And call the new function for the new class. And cast to a toggleable instead of cast to a light. And set it just the same. Now if we were to put a toggleable light inside of this volume, it would be turned on and off, and there's no actual visible geometry for this particular class. And now if we wanted to create something else that used the toggleable, we can create a different child blueprint class, and we'll call this toggleable ball, and we'll just make a ball that changes between blue and green. Add a sphere and change the material to be base material, and event begin play. We'll just grab this, create a dynamic material instance, and then what is the name of the parameter in base material? It is diffuse color. Just copy this out of here, set vector parameter value to be diffuse color, and change this to be green, and then promote this to a variable. We'll call this material, set the material on the sphere 1 to be this material, and then when you go to our functions, override toggle, again it's done as an event, we can take material and do a flip-flop, which will switch which execution runs every time this is run. Just grab 2 of these, copy back that diffuse color, make this one green, this one red, like so. I forgot to plug this in. Compile that like so, and then in here you can just delete this light and put down a toggleable ball. And you'll notice it's green, and it changes between colors every time we click on it. And these are 2 separate classes, the light and the ball. However, we didn't have to change the code within the interactable machine once we had changed it to work with the toggleable class, because both the toggleable light and the toggleable ball are based on that toggleable class. They're children classes. And so that's one way to do that really well. And so I hope you enjoyed watching this, and I hope you learned something about using direct references. And I will be back next video with some more methods of blueprint interaction.